Hello, fourth grade. Welcome back to topic 4, use strategies and properties to multiply by two-digit numbers. Lesson 4, arrays and partial products. And in this lesson, our goal is to use place value concepts and properties to multiply. We're going to be talking about how you can use two-digit numbers to multiply with other two-digit numbers, but we need to talk about how that's going to happen. And so right now you should be on page 141, and let's go ahead and start with our solve and share. Our math tip for this lesson is you can use grid paper or arrays to show the problem. Make sure you show your work, of course.
A theater has 14 rows of seats with 23 seats in each row. How many seats are in the theater? Solve this problem any way you choose.
Now, as a reminder, if you're using an array, that means that you're showing the rows. And of course, you have 14 rows with 23 seats. So that means if you would like to do 14 groups with 23 in each group, that's one strategy you could use. You could also try to solve just multiplying 14 times 23 using an area model. And in case you forgot what an area model can look like, I'm going to go ahead and draw one here. So remember, an area model just looks like a place or our bar diagram. The main difference being that it has one of the factors on one side, 14 here, and then 23. And one of the easiest ways to multiply is to divide it into its place values, 20 and 3. And if you wanted, you could actually divide this 14, but we'll talk a little bit more about that afterwards. So if you know what 14 times 20 is, great. If you don't, then you can break it up into further to a smaller amount. So one of the ways that I like to do that is by breaking this into 10 here and then 4 here. So now I could do 10 times 20, and that will give me 200. And then I can do 10 times 3. And again, we're just using partial products, which will give me 30. Then I have 4 times 20, or 20 times 4, that's fine too. I like to have the larger number in front, but it doesn't matter if you're multiplying. 20 times 4 will give you 80. And then 3 times 4, that'll give you 12. And then we would add all of this up. So now you have 200 plus 30 plus 80 plus 12. Or if you wanted to combine, for example, 30 and 12, that would make right here 42 plus 80. And so now we have 122. And then combined with the 200. So now you should have 322. Now, if, for example, you wanted to do the array, you could go ahead and do 14 rows with 2 10s and then 3 1s. But of course, using an area model would be much faster. So it just depends. If it's easier for you to see the numbers using an array, you can go ahead and do that. And you would have noticed all the 10s, counted them all up, and then did all your 1s and so on. But your product should have remained the same. Let's go ahead and continue to our video lesson where we can talk a little bit more about how to multiply two-digit numbers. So right now we're on page 142, and we're looking at the example there. Make sure that you're following along your text.
How can you multiply using an array? Think about this question during the lesson. There are 13 toy dogs in each row of a carnival booth. 20 rows contain toy bulldogs, and 4 rows contain toy huskies. How many toy dogs are there? To solve this problem, you need to first find how many rows of toy dogs are in the booth. There are 24 rows of toy dogs, with 13 toy dogs in each row. What two numbers should you multiply to find how many toy dogs there are?
Select your answer.
Multiply 24 and 13. Use an array to find 24 times 13. Separate each factor into tens and ones. Color each section a different color. Which section represents 20 times 10? The red section represents 20 times 10. 12, 40, 60, and 200 are partial products. Add the number of squares in each part of the array. Why add rather than multiply to find the product? You add because each part of the model is a part of the product, and the parts add together to make a whole. There are 312 toy dogs in the booth. Check if the answer is reasonable. 24 times 13 equals 312 is close to 25 times 10 equals 250. The answer is reasonable. Why should you check if the answer is reasonable? Checking if your product is reasonable helps to ensure that you have not made an error in your calculations or forgotten to include one of the partial products. Now you know how to multiply using an array.
Good job!
What two-digit by two-digit multiplication is shown by the model? What is the product? Explain how you use the model to find the product.
So you've actually been multiplying using arrays for a while now. The main difference is that now we're going to be using the arrays and of course different colors, so that way you can see what these arrays are symbolizing, especially for two-digit numbers. Now, when you have an array like this where there's no labeling, one of the first things that you can pay attention to is, of course, how many are in each row, so that way you can figure out what the number is trying to tell you. So here, if you count this across, you'll notice that this is 10 by 10. So here we have 10, and here we'll have 10 as well. If you count this across, you'll notice that it has 8 here, but there's still 10, so we know it's 10 by 8. Down here, you'll notice that it's 5 by 10, because remember, we have 10 up here, and there's 5 down here. And this is still going to remain 8. And so now we know that this side will also be 5, because the other side was 5. So these opposites will help you. But of course, you have to pay attention to the clues, so that way you know what is going on for our equation. Now, for our actual equation, you'll notice that we have 10 times 10. That's our first one, the red area. Then we have 8 times 10, or 10 times 8. Both of them work. Then we'll have 5 times 10, or 10 times 5. And then we'll have 8 times 5, or 5 times 8. Both of them work. And then once you get all of those partial products, you're going to go ahead and add them up. So you get 100 here, you get 80 there, you get 50 here, and you get 40 there. So now you can go ahead and put a 0 right there underneath. 5 plus 4, that makes 9. 9 plus 8 becomes 17. So we have a 7 there, carry the 1. Now we have 270 as our actual product. And the actual equation, you'll notice 10 plus 8 and 5 plus 10. So that means 18 times 15 was the original problem. All right, now we're on our guided practice on page 143. And let's go ahead and go over our notes first before we start on our guided practice. For number 1, it says in the example on the previous page, what 4 simpler multiplication problems were used to find 24 times 13? This is talking about page 142. And so we'll talk about it as we start our notes. 4.4, arrays and partial products. I can use place value concepts and properties to multiply. Area models can be helpful by breaking both the factors into each place value. For example, 24 times 13, broke it into 20 and 4, and then 10 and 3. That's why we can do 20 times 10, and that will go ahead and give you 200. And then 20 times 3, you can go ahead and write it right there. 10 times 4, you can write it underneath, and then 3 times 4, can write it there and then fill in these. And you might have noticed that your partial products will match up with these. 20 times 10, that's 200. 20 times 3, that's 60. 10 times 4, that's 40. 3 times 4 is 12. And then when you found your total, it should have gotten 312. Now, another way to solve 24 times 13 is 20 times 10 equals 200, 20 times 3, 60, and so on. Talking about the same ones here as partial products that equal 312. These strategies work because, of course, you could just go directly across. Instead of multiplying it 24 times 13 directly, you, of course, can break it apart into its partial products. These strategies work because of the properties of multiplication, because I can break apart factors and add. When working with area models, I can use reasoning to properly label each part of the grid. For example, here we have 24 times 16. Now you'll notice that I put some blanks here. These blanks are so that way you can practice trying to fill them in. Now, looking here at our area model, and I'll zoom in a little bit so that we have more, can view it a little bit easier. Since we know that this is the longer part, I can go ahead and make a guess, make a prediction that the longer part is going to be my 24. And so the shorter part will probably be my 16. So here I would have 24, here I would have 16. Let me see if I can draw that out. So 24 over here, 16 on top. And that means that now I'm going to go ahead and break this into my 20 and 4, right? This part would be my 10 and 6. So 10 go right here, 6 go right there. Now, why is that important? Well, because now you're going to multiply 20 times 10. Then you would do 20 times 6. And then here you would have 4 times 10, because that's what we had here. And then 4 times 6. And so now I can label the shorter side with the lesser factor, which was 16. I can use my reasoning to label the longer side with the greater factor, in this case, 24. And now I can answer all of my parts. 20 times 10, well, that's going to give me 200. 20 times 6, that's going to give me 120. 4 times 10, that's going to give me 40. 4 times 6, that's going to give me 24. And I can go ahead and add them up. So I have 200 plus 120, and that gives me 320 plus 40, and that was going to give me 360 plus 24. And so now 360 will change into 384, because 6 plus 2, that's going to give me 8, and the 4 is not regrouping. So 384. Now, the reason why I wanted to show you how to do that is because as you're going through your partial products, another way that you could solve this is, of course, by multiplying it directly using this equation. And of course, labeling each partial product as you do that. So 6 times 4, for example, let's start with this one. 6 times 4, that's going to give you 24. Next, we have to go ahead and multiply by the tens. 6 times 20, well, that's going to give me 120. Now you'll notice that I already have some of my similar partial products. Then, now that I've done my ones and my tens, I'm going to go ahead and move to the tens place and now multiply 10 times 4, and that gives me 40. You'll notice that's the same as there. And then 10 times 20, which will give me 200. And so, no matter which strategy you did, whether you did it this way or you do it this way, you should still get 384. And that's why I wanted to show you both strategies, because as you're going through the math equations, you need to have multiple ways to be able to solve in case you get stuck and in case you don't know what you should do. Don't worry, there are steps that you can use so that way you can try to solve using what you know. Let's go ahead and start working on the guided practice. It says in the example on the previous page, what 4 simpler multiplication problems were used to find 24 times 13? So we used partial products. And if you remember the partial products, the equations that we use in order to get 24 times 13, were 20 times 10, 20 times 10, That was one of the equations. Then we did 20 times 3. And where am I getting this information from? The factors right there. Then I did 4 times 10. And then 4 times 3. And so these were the equations that we used. And of course, we got 200 plus 60 plus 40 plus 12 equals 312. All right, for number 2, how can you use properties to help you find the product of 24 times 13? So the properties that we were using were ways for us to break apart using place value, and of course using the factors, so that way we could have our partial sums, our partial products, and then we could add them up. So it says, how can you use properties to help you find the products? I can break apart and add the partial sums. And then we can go ahead and show how we did that. Here, we did 20 times 10, 20 times 3, and so on. If you also wanted to break it apart into each place value, for example, 24 times 13 is the same thing as saying 20 times, or 20 plus 4, and a little bit ahead there. 20 plus 4, which is the same thing as 10, which is the same thing as 24 times 13 is the same thing as 20 plus 4, 4 times 10 plus 3, which can then turn into 20 times 10 times 4 times 3. Or 20 times 10 plus 20 times 3. Oops. Plus 20 times 3. Because it's 13. And then we can continue it down here. And 4 times 10. 4 times 10 plus 4 times 3. I wanted to make it a little bit simpler for our combination because here I had my 4 and I wanted to combine both my 4's together. Because yes, 4 times 3 is one of the equations, but I wanted to combine it with the other 4's. So now we can go ahead and solve it, and you would have still gotten 312. Because you would have gotten 200 plus 60 plus 40 plus 12. That equals 312. For number 3, this equation might look a little bit familiar. Use the array drawn on a grid to find the product. Check if your answer is reasonable. Of course, that means you have to estimate. So looking at 24, I can change that into 20, and 16, I can change that into 15. I can even change that into 20 as well. And so it should be close to 400. Now, looking at this array, the longer one we said was going to be 24. The shorter one is going to be 16. And so now we know this is 10 and 6, and this is 20 and 4. So now we can go ahead and multiply it out. 6 times 4, that's going to be 24. 6 times 20, that's going to give you 120. 10 times 4, that's going to give you 40. 10 times 2 or 10 times 200, that would give you 10 times 20 would give you 200. So now you should have a total of 384. And that is very close to 400. All right, that is the end of our lesson for 4.4. As you go through the homework questions, please make sure that you're reading the directions carefully. If you notice that there's a longer part, make sure you put the larger factor. The shorter part will always be the shorter factor. And if it's closer, you can go ahead and add them up. And yes, we are using the commutative property of addition in order to add partial products in any order. All right, go ahead and start working on the independent practice. Complete the problem solving on the back. Please make sure that you write your answers neatly in order for your work to be complete and graded. All right, I will see you in our next lesson.